Let's take a look at two more examples. So for problem number 3, we have g of x is equal to the natural log of the cube root of x squared plus 5. Now that's a very complicated inside function. If I was just looking at the cube root of x squared plus 5, that alone is a chain rule problem because there is an x squared plus 5 contained inside of the cube root. So that's an inside-outside already, so that's a chain rule, plus all of that is contained inside of the natural log, so that would make it a double chain rule, and we really don't want to do double chain rule. So here's the good news. We are not going to need to do double chain rule here. Instead, we're going to rewrite the original function using properties of logs, and that way we can expand it, get it down to simpler insides, and then we don't need to do double chain rule. So let's take a look at how that expansion works first. So this is where notation will be important. You'll see that I'm still writing g of x. I'm not writing g prime of x because I'm not doing a derivative. I'm just rewriting the original function. So I have the natural log of, another way to write a cube root is to say that it is to the 1/3 power. Okay, and then I can also, because the entire inside is being raised to the 1/3 power, I can pull that exponent out in front. Again, this is a property of logarithms that I'm allowed to pull this out in front. And now I can make this into 1/3 times the natural log of x squared plus 5. Now I cannot split apart the x squared plus 5. I can only split apart a product or a quotient. So this is as far as I can expand. So now I'm going to switch colors and we're going to start finding the derivative. So now the derivative of this, g prime of x, when you have a constant times a function, the constant stays, and then you multiply it by the derivative of the function. Now this is an inside-outside. This is a chain rule version of natural log. Keep in mind, this inside piece is our u. Our u is x squared plus 5 here, okay? So we're going to have 1 over the inside, 1 over u, times the derivative of u. The derivative of x squared plus 5 is 2x. And now all I want to do is kind of merge this all into one fraction, and then we'll be all set. G prime of x is equal to the numerators. 1 times 1 times 2x is just 2x. The denominator will be 3 times x squared plus 5, which you can actually leave it in this factored form. This is a completely acceptable answer. You do not need to expand your denominators at all, okay? If you wanted to, you could rewrite that denominator as 3x squared plus 15, but again, it's not really necessary. But I also write down that you could also write your final answer as 2x over 3x squared plus 15. Okay, so that's another way that you could write your answer. All right, let's take a look at problem number 4. All right, so again, we have a quotient rule on the inside. We've got a quotient on the inside, and if we had to do the derivative of that, we would be doing our quotient rule, which is our low d high minus high d low over low squared. But because it's inside of a logarithm, because it's inside of a log, we can split this apart using the quotient rule for logarithms, that property of logarithms. So again, the original function h of t is equal to the natural log of the numerator, t cubed plus 4, minus the natural log of the denominator, t cubed minus 4. And already I have taken the quotient out of the problem. I've avoided using the quotient rule for differentiation. Okay, so now that I've expanded, I can go ahead and find my derivative. So now I'm going to switch to h prime of t. Now we've got two separate terms here, so we're going to find two separate derivatives. So looking at just this first one right here, this is a ln of u situation, so it's going to be 1 over u, so 1 over t cubed plus 4, times the derivative of t cubed plus 4, which is 3t squared, minus, and now we're going to find the derivative of this natural log separately. So that's another ln of u. So we're going to have 1 over u, or 1 over the inside, t cubed minus 4, times the derivative of t cubed minus 4, which is 3t squared. Okay? So we want to get this down to two single rational expressions. So we're going to write that this is h prime of t is equal to 3t squared over t cubed plus 4 minus 3t squared over t cubed minus 4. Okay? And that's as far as we're going to take it. All right? That is simplified enough. Now, if you were looking in the back of a textbook or on a website like CalcChat, they would probably go ahead and find a common denominator and try to simplify this even further, but this is as far as you're going to need to go. So you just need to take your rational expressions and get them just into nicer, neater rational expressions. You do not need to go ahead and get a common denominator. Okay, so that's it for number 4.